Let's look at some special cases of quadratic inequalities. So when we factor these, we're going to try and find out when does it equal 0, right? So we get x minus 2 and x minus 2, which gives us one answer, just 2. So when we have it on the graph, it's an open dot at 2. But now what? Same exact thing. You're going to try and find the regions. So let's test. We're going to test 0 and 4. Plug them in, and we get a true statement. Remember, this is our quadratic that's coming in here, and what it's actually doing now is just touching the line right there. And so everything here is positive and positive, which is what we're looking for. So we shade both regions. We shade that one because it's true, and we shade that one because it's true. But what we have is a hole here. So when we write the answer, it's from negative infinity to 2, union, and then from 2 to infinity. We have to keep that hole. Alright, what if you have this situation though? So it's exactly the same, but now it's greater than. So when we graph it, we would put a closed dot at 2. And we already know the situation is going to be exactly the same exact test points. So we would shade the same thing because it's just equal now. Well, now that we're including everything, it can be greater than or equal to 0. Then when you write it, it goes from negative infinity all the way to positive infinity. It's all real numbers. So when you get 1 point on your graph, and both regions come out true, if it's not equal to it, you can't include that point. So it's just going to be a hole sitting there. If it does actually equal, though, you do get to include it. So it goes from negative infinity all the way to 2, but we get to include it, and then from 2 to infinity. So everything works. Alright, now let's look at the less than version. So after we solve it, we already know that it's supposed to be 2. It's exactly the same as before, x minus 2 equals 0. So again, this one's a hole, and this one would be a closed dot. Okay, and then I'm going to pick the same values we did before, which were 0 and 4. So we plug them in. We already know the outcome. In this case, it's less than 0. So that would be 4, and that's false. And we plug in 4. That also comes out false. 4 is not less than 0. So what that means is we can't include them. You have to cross them off. It's the whole idea again. The parabola is coming down here and just touching it, which means there's nothing below. There's nothing in our negative region. Nothing in the negative. But if we had greater than 0, everything would be in our positive region, which is why we get to include it. These are positives. These are negatives. Alright, so nothing gets included. Same thing down here, because it's just an equal now. So on this one, we don't have anything here. We can't include the 0, and we can't include this region, which means there's no solution to that one. However, on the other one, we do have a closed dot, which means we get to at least include that 1 point. And that's why these are special cases. So since you have your parabola, it's up here in the positive region. We're going up and just lightly touching it. Lightly touching it. Lightly touching it. Then when you look for the positives, everything's included except that open dot that we can't include. And then here, everything's included, even the closed dot. And then down here, we don't have anything in the negative region. Nothing in the negative region. So all we can do is include that dot for the equal. And that's it. Alright, these are our last two special cases. So solving it, just bringing the negative 5 over, you get x equals I rad 5, plus or minus. This is imaginary, so you can't put that on the graph. What that means is the parabola is actually sitting up here. It's actually 5 units up away from it. It's not touching our line, which is why we're getting a non-real solution. So since it's up here, it won't touch it. We don't have to put any values on there. We can just pick any value we want. In fact, this point we're going to pick 0 because it's always the nicest. So 0 squared plus 5 is less than 0. Is 5 less than 0? No, it's not. So we cross it off, and since that's only one region we have, our answer is no solution. It doesn't work. And it also, think about it, if it's less than 0 again, we're negative. Is there any parabola in the negative region? No, there's not. So, same exact thing. Parabola is above. It's sitting right up here. And this one we're looking for positives. And we'll put a test of 0 again. In this case, greater than or equal to 0. Is 5 greater than or equal to 0? Yes. So on this one we do negative infinity all the way to infinity. Everything gets included. And if you look at the picture, everything is above. Everything is positive. So you plug any number you want in here and it'll come out positive. These are all of our special cases. So we have it to where the graph only hits 1 point. So normally when we're doing these, they're hitting at 2 points. 2 points, 2 points, 2 points. And we're shading outside or inside. Well, on these, it's hitting 1 point. So you're either going to get to include that point when everything comes out true, or not included. And same exact thing, but if the intervals are not included, then all you include is the point. And then if you get an imaginary, that means that the graph is actually not even on there. There is no point of intersection. There's no 0. So it's either going to come out all real numbers or no solution. And that's everything.